Okay, I got the signal that I'm good to go. So, hello everyone, and thanks for having me at the conference. Today, I would like to present you the topic of automated versioning of software. Let's have a quick look at the agenda of this presentation. So, first, I would like to quickly introduce myself. So, yeah, let's call it my bio. Later on, we will review the version number components. We'll break it down, discuss what stands for what, and we will agree on some concepts that I will use later during this presentation. Next, I will compare the manual and automatic approaches to software versioning from the developer's perspective. Afterwards, I prepared a demonstration of one of the automatic approaches. So GitVersion, we will go through two different scenarios and compare what is specific to each of those. I would like to also review the command line interface of this GitVersion tool. And at the end, I'd like to have some time for the Q&A session. So I'm backend developer at VMPL, working with C# and .NET platform for over 6 years. And currently I'm working at projects for semiconductor industry. This is for 2 years already. In the past, I've worked at different projects. So this is not only the things that I know from the semiconductor industry. I can say that at VMPL, semiconductor industry projects are quite popular. So if you are interested in this field, you might be interested in cooperation with VMPL. As a developer, I am DevOps oriented. So on a daily basis, I do write code, but I'm also maintaining the build pipelines and stuff around this. What also gives me quite a lot of joy is the modernization of tech stack. I can tell you that in the current project, we migrated the code base from SVN to Git, the .NET framework to the newest .NET Core. That was .NET Framework 4, so that was basically the whole the whole process of modernization, and that also included the migration from Entity Framework to the Entity Framework Core. For those of you who are not from the .NET world, the EF is basically a data access layer, usually quite complicated part of the application. So yes, I think that those aspects are pretty popular recently because quite a lot of projects want to go through this modernization way, especially to core and the EF core. I also wanted to mention that I'm a graduate of the Wrocław University of Technology. I've completed the control and robotics and computer science faculties. Okay, so let's dig into the topic of versioning. So what you can see is the example of version number, and let's see which part of the version number is responsible for what. So the first number is called major. And that's, as the name says, that's the most meaningful number of the whole version number. So change to this number usually means a huge update comparing to the previous version. So the definition says that if you change the major, you made some incompatible changes to the API. So say you maintain a JavaScript framework, and if you increase the major, the users can expect some changes that will be required after the update. So I think JavaScript is a good example because the frameworks are changing quite rapidly. So the next number is minor, and minor usually means that there is something new that you can make use of. So new functionality is coming, new features, but they are backwards compatible. So no changes to API should be expected. That's the ideal case. I know that that's not always the case because some people do not follow this scheme, but I mean, this is the definition. This is we're speaking of the ideal world. The third number is called patch. And incrementing patch means that you did some backwards compatible bug fixes. So no new functionalities, just some improvements, bug fixes. So the user should be able to safely update the package, or should expect no drastic behavior changes from the last update. Plus, at the end of the version number, we have this dash alpha. And this is optional. Probably in most, as a user, you most of the time don't see this kind of suffix to the version number. But so that's why it's called the pre-release label. So this is for developers. This is for developers to indicate what this pre-release really is. So whether this is alpha, beta, whatever. So they can store some meaningful information in this place. I will show you later in the examples what kind of information you can include here. I wanted to go quickly through the stable versus unstable version, because I will use this term later in the presentation. So stable version are like those. So those are the, let's say, the production version, the ones that were released to the user, to the customer, whoever, right? The unstable version has this pre-release label. So it carries some more information, what this version is, and what to expect from it. This is used by developers, by the development team, in the development process. So the stable versions are production ready. The unstable version are non-production ready, are dedicated for the lower environments, like the development, test, integration, whatever you call your environments in your project. I wanted to show you how the process of manual versioning looks like from the developer perspective. This is the kind of a process that I've seen in several projects that I worked at previously, and I think that might be quite common still in 2021. So let's assume we have the standard tools. We store our code in a Git repository. We have some kind of build server running, whether this is TeamCity, Jenkins, whatever. As developers, we write code, usually, right? So we push our changes, and we want somehow indicate to the user or the other development team members what are the changes, right? So we need to go to the build server, adjust the version parameter, or maybe it's even stored in the repository. I mean, whatever. The parameter has to be somehow provided, and then we start the build. So this approach has quite a lot of drawbacks. One of them is that the developer must know the version number, and that's really an issue because people usually have no idea what kind of versions this should be, and they prefer to either stick to the one that was used previously or some kind of default. So this is something that we lose at the moment of the build if we don't provide the proper version number. So this also requires a manual step. So someone has to do this. A person has to do this, and this approach is not really friendly for the automated environment because we need to have some kind of defaults, and defaults usually have no meaning. How does this manual process compares to the automatic versioning process? Here we have similar configurations. So the project uses the Git repository and the build server. Of course, we push our changes, and then the magic happens. So the build is triggered, and the build is versioned automatically. So this is something that we need to configure once at the beginning, ideally, and afterwards everyone is just making use of that. And yeah, the benefits are quite easy to guess. So we get meaningful version numbers because those ones were calculated for us by some kind of tool, like GitVersion that I will discuss later. This approach is maintenance free. So from developer perspective, I just need to do my job. I just need to write the code. Plus, releases are recorded in the repository. What does it mean? So to do your versioning properly, you need some kind of some kind of hints for the calculation tool, and usually those are tags that you put to the repository, Git tags that are created in the repository. So it's possible to deduct when and how to increment the version the version number components. The tool that I wanted to suggest is called GitVersion. And as I've already mentioned, it takes advantage of the Git tags. It supports multiple different branching strategies. So regardless the branching strategy you use, that would be a way to go for you. GitVersion also forces good practices, because if you use the manual process of versioning, usually it doesn't matter whether you do the tags in the repository or no. You can easily forget it because you don't get any value immediately. So this is something that is easy to forget. And when the issue comes from production, for example, then you start to investigate and you see, oh, we have no tags, we have no idea where to look at. What version should we review? Where should we look for the bugs? And GitVersion is also cross-platform, so regardless the platform you are on, you can make use of it. And so let's have a look at the demonstration. First of the demonstration I prepared. This is demonstration for the mainline mode. This is one of the modes that GitVersion can work in, and it's dedicated for a simple branching strategy with master branch, the central master branch, or main branch, as it's called recently, plus some feature branches, and alternatively hotfix branches, because you have to have this process for hotfixes. I mean, usually you have to. So the idea is that in this branching strategy, the features are developed in separation from master. So each time you want to start a feature, you create a separate branch, add your changes, and then merge. Once completed, you merge it back to master. And this is how it goes. There are some core concepts about this simple mainline mode that makes it very usable and friendly for the developers. So there is a concept that each build that is built from the master branch is stable. So you assume if you merge something to master, it has been tested, it has been verified, it basically fulfilled all the it fulfilled the definition of done in your project. So you can assume it's stable. On the other hand, builds on the feature branches are unstable. So they are the development versions. So they have some kind of suffix. Let's have a look at the demonstration now. I wanted to do it like this. So here on the left-hand side, the Git tree will be built. So each dot stands for a commit. We will see some branches here. Here are the meaningless commit messages, plus the branch that we are currently on. So in this case, we are on master. And we create some tag at the beginning. This little thing stands for a tag on this visualization. And we basically trigger a build. What kind of number will be used for this build by GitVersion? It's easy. The most important thing for GitVersion are tags. So it looks whether the commit is tagged, and it just picks the version. That is the easiest case. So it's, yeah, the tag is present. The version will be 1.0.0. Then we switch, we create a branch, and we create a commit on the branch called feature blue. And it also triggers a build. In this case, the Git version will generate following version. It will be deducted from the previous commit, from the parent commit. So in this case, it was 1.0.0. So we are on a new branch, on a feature branch. So first, Git version increments one of the numbers. In this case, it incremented the patch value and adds some suffix. By convention, it removes the feature and leaves the blue. So it gives us the information that we are on this build was done from the branch blue. And it is one commit different from the last stable build. So if we make another commit and one another, we will see that the last number is incremented, because this stands for the number of commits that we are away from the last stable build. So in this case, this is 3. Later on, we merge the changes to master and trigger the build. And on master, as I mentioned previously, each build on master is stable. So the version is 1.0.1, a stable version with the updated patch number since the last stable version. As simple as this. So another branch with some commits, you can see that here it actually incremented the patch version to 2 because it had a look at the previous stable version. Therefore, we have 1.0.2 green and the number of commits that are different from the last stable. This is as simple as this. And this approach can be useful if you are working in this kind of branch strategy. I thought it's also useful for demonstration because it's simple and hopefully easy to grasp the idea behind the automatic versioning. So that's the first example. The second example is a bit more complicated because the branching strategy is a bit different. So beside the master and feature branches, it has also the develop. To be honest, this is quite popular approach, at least from my experience. Most of the projects I worked at followed this branching strategy. And the same, features are developed in separation from master and also from develop. And yeah, we have workflow defined for hotfixes. And what makes this mode different from the mainline is that not all builds on master are stable. So that means if you just pick random commit on master and run a build for it, it will not be stable. In this configuration, by default, they will have the CI suffix, the builds from master. To make it stable, you need to tag them. So let's have a look at the example. We again start on the master branch, create a 1.0.0 tag, and then we switch to develop and create a feature blue branch from develop. And after you make some commits, you can see that the behavior is quite similar to the previous approach. The small difference is that by default in this configuration on the feature branches, GitVersion increments the minor number. This is just the idea of the default values. You can override that. I'm just speaking of the defaults, whether it matters or not. And again, the 1, 2, 3 number of commits different from the last stable build. Then we decide to merge those 3 commits to develop, but I didn't do the merge commit. I just used the plain merge. So without the no FF flag, basically. And when you start the build from develop, it by default it will add this alpha suffix to the version. And still the number of commits from the last stable is maintained because there was no stable build done in the meantime. Another branch is created called feature green. You can see similar scheme. So the 4 and 5 again are incremented. And also the 1 remains. There is no 2 now because we didn't create it. So we haven't created the 1.1.0 stable build yet. So it is all equal among the different feature branches. merge to master creates version alpha.5. Sorry, that was merge to develop. Now we merge to master, and we also create a tag, which means that now we want to create the release and send the artifacts to the user, whatever. The version is stable, right? 1.1.0 after we create this tag. Then the development goes on, and again, someone starts the new branch. And now you can see that the minor number is incremented. So we start now, we just started to work on the 1.2.0. And also the number of commits different from the last stable has been reset. So we start again from 1. Then after we complete implementation of this feature, we merge the changes to develop. So we get the alpha version. And we merge changes to master and create a tag. So we end up having the stable 1.2.0. So yeah, that would be that for the second mode. If this was confusing anyhow, then we can come back to that during the Q&A session. Feel free to ask any questions if anything was unclear. Now I would like to show quickly how to install and how to use the CLI of this tool, because of course you need to somehow make it working in your build pipeline. So there are several possibilities how to install this GitVersion utility. For the .NET developers, it might be an option for you to go for the .NET tool. I will review that approach soon. You can also install that using the Chocolati. That's a very neat package manager for Windows, and GitVersion is supported there. So you can also have a look. If you are on Mac and Linux, Homebrew is recommended. I haven't been using that because I'm a Windows person. Yeah, also you just can have a look at the documentation. It's not perfect, I would say. At least all the nasty details are kind of you somehow need to figure it out yourself, need to experiment, but you can get some insights from the documentation, let's say. Okay, so GitVersion can be installed as a .NET tool, which is kind of useful when you are a .NET developer. And it can be installed globally using this command line, and afterwards you can use the .NET GitVersion command. I just wanted to mention that because it's possible to install tools using the .NET CLI. And usually this is very helpful for you as a developer. And it is the most helpful if you are installing the tools as local tools. So not only you say that let's install, let's say, this GitVersion tool on my machine, but installing as a local tool, it means local to the project. So it will create a JSON file in your project with the list of tools that you have dependency on. So let's have a look. Yeah, this basically makes the installation much more portable. So you can create the tool manifest. It will create the JSON file within your project, so you can commit it to the repository, and other people can make use of that. And then you can install the tool, and it will add an entry to the JSON file. So other members of the team will be able to restore the packages. So that means that you don't care about configuration of the development environment here, that you say, oh, you need to install this tool, otherwise the build will fail. No, you just include this .NET tool restore in your build script, and it will download all the tools that you need, even for build, just as a dependency package like npm NuGet. So this is quite neat approach, and I quite like it because I didn't have to talk to the build server admins to install me some tools. So then just include that in your build script, in your repository, and you are independent. You can just use tools of your choice, versions of your choice, and keep all neat and clean. Yeah, here is also a link to the documentation page on MSDN docs, how to use the local tools. But this is only for the .NET developers. So I know that it might be not for us, not for all of us. So the GitVersion CLI, it is basically, the Git version is configured, can be configured in the GitVersion YAML file. So it has some defaults, but if you want to override it, you just add this GitVersion YAML file, and then you can start with the contents to make this tool to work for you as you wish. But the creators had the idea to add this, to implement this kind of wizard approach that will just help you to go through this configuration. So they find maybe that editing the YAML file manually might be not the best idea. So let's make this tool a bit more human-friendly, developer-friendly. So, for example, you can specify the mode, and I will show you how it looks like. So, as you can see, I typed the GitVersion init. It ran it asked me basically at the beginning, which would you like to change? And then you have some options. You pick it. It's just like, if you call some kind of hotline, and then you get some options and you select the number. Maybe it's silly to tell it to developers, but why not? So it will guide you. It will ask maybe sometimes some helpful questions, but at the end, I'm sure that you will have to experiment a bit, try different approaches, which one will work the best for you, and then just make this configuration. Okay, so maybe now one of the most important questions. So how do I get the calculated version? So it is as simple as typing git version in the root of the root folder of your repository, and it will return you a JSON object that contains all different helpful information you might need in order to use in your use case. This is the standard reply of the Git version. So here is the one that we want. This is the full semver, which stands for full semantic version. Semantic version is this format basically that we discussed previously. 1.0.3 in this case. But you might also want somehow to store to use this informational version that contains the branch name, even if this was the main branch, the central branch, let's say, including the full commit hash. So this is quite helpful to use sometimes those informations. And yeah, if you want to play yourself with the numbers, you can use those fields. I would like also to show you how to extract the concrete value from this JSON. it is just using this show variable parameter, and you just type the name of the field, and voila, it returns you just this one particular value. From the .NET developer perspective, I also wanted to show you how I add this up as a parameter to my build, so my artifacts are versioned properly. So in case of .NET build, it's just adding this version parameter and then providing the version calculated by GitVersion. And as I mentioned at the beginning, it's also super helpful to include the commit hash in the metadata of your artifacts. Yeah, commit hash is just the unique ID of the commit. So if you have this number, you can say that this build was made using this commit. You can just identify it one-to-one super easily. So in case of any issues, you know where to investigate, where to start from. And yes, for .NET CLI, you just pass it using the source revision ID. And just to prove that this whole talking was not about something imagined, let's say I wanted to show you also the real world case. This is Automapper DLL properties. Automapper is one of the most used libraries in the .NET world, and they do follow those conventions. So they have the semantic version format, so 10.1.1 in this case, plus the commit hash included in the stable version. So that would be it from my side. Thanks a lot for taking part in this with me. And if you have any questions, then this is the time for to ask questions. I can see that there are some questions actually in the comments. I was not able to see them before, but let me have a look at them now, if you don't mind. So the question is, why do we need patches? Can we obey without them at all? I think we can. We can live without them, but there are some standards set, as I mentioned at the beginning, or maybe not at the beginning, later on. There is this semantic versioning standard, and currently the version is 2.0.0. So this is a standard that a lot of companies follow, and it is understood widely by the developers that you increment which version number you increment when. And I highly recommend to following standards. So that would be my answer to this. Next question is, what are the best examples? Oh yeah, thank you. What are the best examples when the first digit changed into the second one? Yes, so to be honest, in the real life, it might be not as easy as the standard says. So the standard says some backwards incompatible changes were made to the API, but usually sometimes it tells nothing to the users. So in my case, usually it's like the manager comes, or someone from the someone who is basically higher than you in the company, and says, now we should use the version 4 instead of 3, and there is no reason behind that, because the customer will. This is, I don't know, we have another phase with the customer. It's just depends on the project. So in case of Python, I'm sure that there were some incompatible changes or some core changes to the API, but I have no details about that. Sorry. How can we test that the next version of or generation is compatible to the previous ones? So usually you have to just trust the creators of the package, because actually when you are having a dependency on some third-party tool, that's a huge yes, you trust the people a lot that who create this package, that they have no bugs. Usually we try to use let's say technology standards, some tools that are used widely in the industry, and we just hope that if no one else had issues with this tool, then we will also not have. But as we learned several days ago, this logging framework in Java had some security holes. So yeah, it might be, it's just impossible to tell that the developers followed the higher standards. This is what we hope for, but of course some issues occur. So it's actually good to follow this semantic versioning, because at least we can understand what the creator wanted to tell us about this new version, whether we should update the API. We should maybe try whether this builds or fails. We will know it immediately after we make this update. Jak wersjonuje się popularne oprogramowanie? So how to version popular software? I don't know what to understand by popular, but as far as I know, I will mention that for the next time. This semantic versioning is the way to go. So no reason to reinvent the wheel, write new standards. Just take whatever is available. In this case, that's a pretty well documented thing, quite easy to understand, and widely used. So yeah, semantic versioning is the way to go. Okay, no play merge, that was plain merge. I mean, in Git you can either plain like a plain or merge without any additional flags or switches. So if you just do git merge branch, it will try to just take the commits and add directly to your branch, or just move the speaking of the Git language, just move the pointer of the branch to the last commit of the branch that you want to merge. So it will not create any additional commits on your branch. So this is also a widely used approach. It depends on the project. So basically, if you want to create this additional commit merge commit, you need to add this dash no ff flag. So those are two different approaches. So in which place we should store the version number? I think that the best place for that is the Git tags. So the Git tags are basically, tag is a pointer to the commit, and it can be named, it can have some description, and it gives you, this is a place to store all the information about this release. So you can say that release 2.0 was built using this particular commit, and this is all information you need. So this is the best place to store the version number. Linux should be supported. because there is implementation for also Linux and Mac, so no worries about that. Okay, so looks like no more questions. So thank you very much for your attention, and yes, that was a pleasure to to present it to you.